Hello. Good afternoon. Can everyone in the back hear me okay? All good? All right. My name is Matt. I work at Square. And today I'm going to show you how to add powerful tools to your debug builds to enable you to move incredibly fast. So I am going to be showing a lot of code today on the slides. Please do not try to copy it. I'm going to be moving pretty quickly, and I just want you to get an understanding of what's going on. All of the code you're going to see is taken right from this project on GitHub, U2020. It's a sample project released by Jake a year or two ago. And in addition, all of these slides I will be posting on SpeakerDeck. So just follow me on Twitter or Google+, and you'll get the link. So we're going to be leveraging a few libraries today, or a few tools. First of all, Gradle build variants. We're going to be adding a whole bunch of code that we only want to ship in our debug builds and not in our release builds. If you're using Maven or Ant, this might be possible. Good luck. I have no idea how to do it. We're also going to be using Dagger version 1. If you don't know Dagger, I will try to explain the key concepts that we're going to be using, but there's talks online by Jake and a few others about how to get that set up. Retrofit version 2, Jake talked about this yesterday. If you're still using version 1 and you don't want to switch, just look at the U2020 project as of a week ago. I only moved it over to Retrofit this week. OK HTTP, this is going to be our HTTP client. And also for logging, we're using Timber. None of these are strictly required to get any of this to work. However, they have been designed with basically this talk in mind to allow you to plug into them and have debug-specific actions. So our Gradle build configuration, we're going to have two types. It's going to be debug and release. And we're also going to have two flavors, internal and production. And this produces 4 build variants. It's a cross product. So we're going to have internal debug. This is where all of the debug tools are going to live. Internal release, this is what we ship internally at Square for internal and beta testing. Production debug, this is simply just a debug version of the release build. And then production release, this is what we upload to the Play Store. All right, so we're going to be adding a whole bunch of controls today. And we need somewhere to put them. We need somewhere that's out of the way, but accessible from any screen. And for this, we've chosen to use a drawer. Simply swipe from the right on any screen, and the debug drawer will pop out with all your controls in it. So let's take a look at some code. Here is a very basic main activity. It inflates our main activity layout and sets that as the content. This is kind of what it looks like. We have our content, and we have the activity. It inflates it and sticks it into a container that it owns. And what we want to do is we want to be able to drop a drawer right in the middle there and attach our debug controls. And we want to do this in a way that is overridable on our debug builds and doesn't add any complexity to the release builds. So first, we're going to define an interface. It's called app container. It has one method in it called bind. It takes an activity, it does whatever it needs to do to the activity to get it set up, and it returns a view group that the main content is going to live in. We have a default implementation. All this does is it finds the content view. This Android R ID content is just the unique identifier that the activity is using. So basically, we're replicating said content view in this implementation. This is a Dagger module. So if you don't know Dagger, all we're doing here is we are saying when somebody requests an app container instance, give them this one. So we're going to update our activity. We're first going to get an instance of our Dagger object graph. Injector is it's a very simple helper. You can find it in U2020 if you want to see the details. and then we're going to call inject, which grabs a copy of app container and assigns it to our local variable. We're then going to call bind on our app container to get the content container from it. Then we're going to take this set content view, and we're going to instead inflate our layout into this container that we got from our app container. All right, so let's take a look at the debug code. This is the frame that we want to use on our debug builds. You will see in the top that it lives in source internal debug. So this means it is only going to be included in the internal debug build. We have a frame layout. This is where all of the main content is going to live. And then we also have a scroll view, which is where all the debug content is going to live. We're going to create a debug view. It's very simple. It's going to inflate the content and attach it to itself. So this is the layout that we just defined previously. And now we're going to create a debug app container. This implements our app container interface. It lives only in the internal builds. And for bind, we're first going to set the content view to be our activity frame, or our debug activity frame. We're then going to grab a reference to the drawer, and we're going to add the debug controls to the drawer. And then we're going to return the content frame where we want all of the real content to live. Now we have a debug UI module. This is going to override the provider that we defined earlier in the regular UI module. And instead of returning the default app container, we're going to return the debug one instead. And that is all that's required to add in a drawer only in debug builds. So let's start putting things into it. Let's start with something very easy, but extremely useful. And that is endpoint switching. We hit the drop down, and we can switch between production and staging endpoints on the fly without having to recompile the app. So we have an API module, and we're going to define the production endpoint that we're going to be using. This, for our case, is just api.github.com. And then we have a provider for this, which is just going to return that statically. Now in our debug builds, we're going to set up an enum called API endpoints. This is going to define all the endpoints that we want to switch between. We have production, we have staging, and we have custom. We're going to give them a little bit of body. We have a name that we want to show in the spinner, and then we have the URL that they are going to use. For custom, we're just going to use null for now. We want to store the current endpoint in the shared preferences so that upon app recreation, we can restore it. We're going to use a class called string preference. This is in U2020. You can find it. It's a very simple wrapper around shared preferences that allows us to inject preferences for specific keys. It just has 4 methods: set, get, isSet, and delete. We are also going to provide, or in our debug build, we're going to override the endpoint, and we're going to use the endpoint from our shared preferences. In the debug view content, we're going to just add a spinner called network endpoint. And then in our debug view, we have a method called setup network section. We are going to inject our endpoint. Then we are going to create an adapter to populate the spinner. This enum adapter is a helper that we have. You give it an enum, and it'll automatically populate items in the adapter based on all the values in the enum. We're going to set the current selection to what we're currently using. We're going to add a listener, and whenever it changes, if it's a custom endpoint, we're going to show the dialog to allow you to manually enter the endpoint of like your local server on your computer. I'm not going to show how to create the dialog. It's pretty straightforward. I will show how to handle the results. And then we have a method called set endpoint and relaunch. Why do we relaunch? Because we have a lot of dependencies in our Dagger graph, what endpoint you're currently connected to. And the simplest way to change all this is to just relaunch the entire activity and recreate the graph. So set endpoint and relaunch, pretty straightforward. We set it to the shared preferences, and then we're going to use this tool called Process Phoenix by Jake, which just recreates the entire activity. All right, so now you can easily switch between endpoints, production, staging, custom. What else can we do? One tool that I like to use sometimes is setting up a network proxy, like Charles, and inspecting the network traffic that we're getting from the server. If you've ever tried to set this up on Android, it's fairly complicated. You have to set it on an OS level, and it's a lot of steps. However, with OKHTTP, we can add a network proxy setting to our debug drawer. All right, in our data module, we are going to provide an OKHTTP client. We are going to use a static helper method to do this. It'll make sense shortly. So all we're going to do here is we're going to create a client, do whatever you usually do to the client to set it up, set timeouts and whatnot, and then return it. We're going to create a network proxy preference. This is just a convenience class around string preference so that we can get a proxy object, which is what OKHTTP uses. In our debug data module, we're going to override the client that we are providing. We're going to reference that same static method that we created earlier. And this time, we are going to set the proxy to the current proxy in the preferences. We're also going to override the SSL socket factory with a bad one that accepts any certificates because Charles is going to screw with your HTTPS settings. Please don't ship this code to production. It is very insecure. We're going to add another spinner to our drawer. And we're going to set it up in the debug view. We have a proxy adapter here. We're going to set the adapter to the spinner. We're going to set the current position to the custom view. And we're going to handle the selection changes. If you've selected no proxy, then we're just going to delete the proxy. Otherwise, we're going to show another dialog to allow you to enter the address of your proxy server. Once again, I'm not going to show you the dialog code. It's fairly straightforward. Sorry. However, handling the results of the dialog, we're going to set the value back to our preferences, and then we're going to update the OKHTTP client to use this proxy. All right, so now you can inspect network traffic. However, you're still talking to a server, and you can't really move fast when you're talking to a server. I know this happened a lot for us when you're starting to ramp up on a new feature. You ask your server team, hey, is this endpoint ready yet? They say no, so you have to pretend like it's ready. Or as you're working, staging goes down. What do you do when staging goes down? You really can't test any of your code. So we're going to completely eliminate the need for a server. And for that, we're going to use mock mode. So all we need is a contract from the server for what the requests and responses are going to look like. And then we can completely mock out the server calls and never talk to a server at all. Let's take a look at how that works. So this is our retrofit service or retrofit interface. In this case, we are talking to GitHub. We have an endpoint where we are getting the trending repositories. It takes in a search query, a sort, or a sort value in an order. Here is in our API module, we provide our GitHub service. We just use retrofit to create it. Now this is what our API endpoints look like. We're going to add another value called mock mode. The address doesn't matter. We just need something that compiles. We're also going to add a helper method called isMockMode, which takes the current endpoint and just tells you whether or not it's mock mode. In our debug data module, we're going to provide this value for injection using Dagger. All right, so now we need a whole bunch of mock data to fill our list with. In this case, we have a Dagger repository. We have a whole bunch more that we use to fill that out. Now we need to create our mock service. As you can see here, it's implementing the GitHub service interface. We're going to override the repositories method. And instead of talking to the server, we're just going to return a static value. In this case, it's a list of all of our repositories. In our debug API module, we're going to override the GitHub service that we provide. If we are in mock mode, we're going to use mock retrofit to create our service, and we pass it the mock service that we just defined. So if we're in mock mode, we're going to call our mock data. Otherwise, we're going to return the regular retrofit service. And that is all you need to do to override talking to the server. But we have one problem. What we just did was the happy case. This is what happens when you call the server, they give you data, everybody's happy. There are a whole bunch more cases that we need to handle when we are developing these screens. We have, what happens when loading takes 5 seconds? What happens when there's network error? What happens when you got a response from the server, but there was no data? What happens if there's one result? What happens if there's pages of results? These are all things that you need to test while you're developing. So we've already taken care of the happy case. Let's focus on these two, loading and network errors. We're going to add 2 new controls to the drawer, one for controlling the network delay and one for controlling network errors. In our debug API module, we are first going to provide a network behavior. This is what mock retrofit uses to configure how it responds. And we're also going to provide a mock retrofit. In our debug view, when we're setting up the network, we're going to configure a delay adapter. This is a very basic adapter. It just has a static list of values, 250 milliseconds, 500 milliseconds, etc. We're going to set the current value based on our preferences. We are using milliseconds. And then once you've selected a new value, we are simply going to update the network behavior in retrofit. And we're going to set the value to our shared preferences so we can restore it later. We're going to do the exact same thing for network failure. In this case, it's going to be a percentage, 0 to 100. And that is all you need to do. So now you can say, now you can configure that a network response will take 10 seconds to come back or 250 milliseconds, or you can say that 100% of the time you're going to get a network error. Now let's handle what happens when the network works, but we want different results from the server. This is where we left our mock GitHub service. As you can see, we have a static response here. So we're going to pull this out to its own file called mock repositories response. And we're going to add a couple more one for when there's one result, and one for when it's empty. We're going to add a couple helpers to our mock GitHub service. This uses reflection to save our current responses to preferences and restore them after. This doesn't really make sense in this case because we only have one value that we're saving and restoring, but for cache we have like 20 or 30 endpoints, so this comes in very handy. So first we are going to grab the response that we want to return. Since there is sorting involved in this and we don't have a server to do the sorting for us, we have to do that here in the client. I'll leave that up to you. And then we're going to return the response. So now to configure this on demand in the client, we're going to add yet another spinner to the debug drawer. In our debug view, we have a method called configure response spinner. This is a helper, once again, very useful when you have lots of endpoints. It's going to take in a spinner, and it's going to take in a class to populate the spinner with. We're going to set up an enum adapter. We only want this enabled when we're in mock mode, because there's no point in controlling the response when you're talking to staging or production. We're going to set the current value based on the response that's currently selected. Then we're going to handle changes. Oops. Come on. We are going, once you select a new value, we're going to update the response in our mock GitHub service. All right. So now we have a mock behavior section set up. All we need to do is we need to pass it reference to our spinner and the enum class with all of the different responses that we want to allow you to choose from. That's it. Now you can configure all the responses from your server. So if you ever come up with a new edge case, just add a new value to your list of responses, and then you can continuously test that as you make changes. All right, so we've now completely severed our dependency on the server, but we still have more external dependencies. So as you can see here, tapping on a repository takes you out to the browser. Now imagine this was an email intent. Cache used to deal a lot with emails. Emulators, when you set them up, they do not have an email client configured, and you can't be expected to set up the email client on all the emulators you want to test with. So we're going to set up intent capturing. Now, tapping on a repository takes you to a special debug activity that we've created, which dumps all the contents of the intent so you can inspect them without actually having a way to handle those intents on the client. So how does this look in code? Well, we're going to need a new interface. We're going to call it intent factory. Here we have a method called create URL intent. You may have more, maybe create email intent, create share intent, stuff like that. Here we have our real implementation. All it does is just creates an intent for us, sets the data, and returns it. In our data module, we are going to create a provider for this so we can inject it later. Now let's create our external intent activity. We have an action for it to start it, and then we also have an extra that we're going to pass to it, which is the base intent that we're going to use to dump the data from. We have a helper called create intent, which is given an intent like open URL, we're going to wrap it in an intent that opens our activity instead. You can see we are putting the base intent into our current intent. Then in our onCreate method, we're going to pull out the base intent, and then we're going to show all the data from it. In our debug data module, we're going to first create a Boolean preference, which allows us to toggle whether or not this is actually applying on the fly. Now we're going to create our debug implementation of our intent factory. So we're first going to need a reference to the real intent factory, whether or not we are currently in mock mode, and whether or not we want to capture the intents. So first, we are going to grab the base intent from our real intent factory, the one that we would launch if we weren't capturing. And then if we're in mock mode and we want to capture the intents, we are going to use the external intent activity to wrap our intent and return that. Otherwise, we're going to return the base intent and let it be fired as normal. So in our debug data module, we're going to override our provider for our intent factory and return the debug one instead of the real one. All right, we have now eliminated all external dependencies in our app. We are able to test everything in the app without leaving it. Let's talk quickly about bug reporting. I want you to think about how currently internal bugs are submitted to you. Does somebody send you an email and say, something's broken? Does somebody walk over, tap you on the shoulder, show you their phone, and say this isn't working properly? How easy is it for you to get a screenshot from these people who are filing your bugs? Do you ever get screenshots? What about the internal logs? And how easy is it for you to file your own bugs? Say you're out at lunch playing with the app and you notice a bug. On all of our apps inside Square, all we need to do is press and hold with 2 fingers, and then we get this dialog that lets us fill out what happened, and it automatically includes a screenshot and all of the logs from the device. And to do this, we're using something called Telescope. As I said, press and hold 2 fingers to trigger a bug report, and it will automatically take a screenshot for you. It calls your listener to handle the report, and you can do whatever you want here. You can send an email, or you can open a ticket via some internal API. We personally do a combination of these. We have an email address that we can send bug reports to, and it automatically creates Jira tickets for us. We do this because we like to be able to create tickets from outside of our VPN. And this is available as a library on GitHub. All right, so we want to be able to attach logs. So for that, we need somewhere to store all our logs. What better place to store logs than in a lumberyard? So this is in source internal, not in source internal debug, because we want to reuse this for both our local dev builds and our internal beta builds. So we just need a place to store all of our logs. For this, we're using a deck. We have a method called add entry. And we're going to expose a Timber tree here. Timber is a very cool library. It allows you to hook in different listeners onto Timber for how to handle logging events. So our tree, when it gets a log message, it just calls our add entry method and saves it to our deck. We also expose a method called save. What this does is it takes all the logs, saves them to a file, and allows us to attach this file to an email, let's say. So Telescope's callbacks are called lenses because it's punny. We are going to create a bug report lens. It needs a reference to our context and our lumberyard. It's got a method called onCapture. This is where you get called when a bug report has been triggered. It gives you a reference to the screenshot. And what we want to do here is we want to show a dialog. I'm not going to show you dialog code. If you want to see it, it's in U2020. And then when the dialog has been, when you hit OK in the dialog, we have a method called submit bug report. So what you're going to do here is you're going to create an email intent, set the recipient to your email address. You're going to pre-fill the body with all the device information that you want, and you're also going to attach the screenshot and the log file from Lumberyard. So this is where we left our debug activity frame with our drawer layout. This is the content view. And we're going to change this, instead of being a frame layout, to being a telescope layout. In our debug app container, we're going to take this find by ID. We're first going to pull that out into our telescope layout. We're then going to configure it with our callback, our lens. For our internal beta builds, we're going to have a new activity frame, which is simply just a telescope layout. We're going to need to create a telescope app container. We are going to set the content view to be our internal activity frame, which is just our telescope layout. And then we're going to configure it with our lens, basically just like the debug app container. We're going to need to create a new module in our internal release build to override our app container, and we're just going to return the telescope app container in this case. So some more tools that I didn't have time to cover today. Mock push notifications. Add a button to your debug drawer and have it trigger a push notification into your system tray. Reset various flags that you have in your app. We have one for whether or not you've currently finished onboarding. Have a button that just resets that flag, so next time you open the app, you can go through onboarding again. Whether or not you've seen help windows, etc. Shortcuts to various screens in your app. There's nothing more frustrating than every single time you make a small UI change, having to open your app and drill down 6 screens to get to the screen that you're currently working on. Add a shortcut to your debug drawer that takes you directly there. Database operations. Whenever we change our database schema, all we need to do is open the drawer, hit delete database. Show all the logs. We have that Lumberyard that stores the logs. We can add a dialog that lets you scroll through the past 200 log entries so you see what's been going on. Debug activity. This is extremely useful, very simple. So we have our debug view, which is the contents of the debug drawer. And one problem that we frequently run into is we make a change, and we open the app immediately crashes because our data is in a bad state that we're not expecting. And we know how to fix it. All we need to do is just delete that piece of data. But having to clear the entire app data is really annoying. So you can create a second activity that all it does is it inflates your debug controls. And that way, you don't have to run any of your real code, and you can access all those buttons that you've added in your drawer, like deleting the database, for example, or resetting flags. This is pretty simple to do. You create a new activity, you register it in your internal debug manifest, and then with Gradle and manifest merging, it gets merged together, and then it's only available in your internal debug builds. All right, contextual actions. These are really fun. What are contextual actions? Well, let me explain to you contextual actions. For this, we're going to take a look at cache. Here we have an entry field for linking your debit card. It takes 16 digits, and then once you've entered 16 digits, it transitions into another form which takes in a 4-digit expiration, a 3-digit CVV, and a 5-digit zip code. So to get past the screen, you're going to have to enter 28 digits and then tap next. This is really frustrating, especially if you don't even want to test the screen, you just want to get to the next one. So on this screen, you swipe open the drawer, and you have a special action called Enter a Valid Card. And this button only appears when you're on this screen, and tapping it will enter a valid card into the field and tap next for you. Don't have time to cover the implementation of this, but there are examples up on U2020. They're very contrived examples because U2020 is too simple. So I had to add actions like scroll the list view for you. So some final thoughts. Fork U2020. We've done all this work for you. If you're starting a new app, you can just fork the project, delete all of the GitHub specific code. There's not a lot of it. And then you get all of these debug controls for free. Your time is valuable. Don't waste your time recompiling your app every time you want to change your endpoint, stuff like that. Add debug controls. That is it. Are there any questions? Yes. Right. So the question is, how do we handle switching endpoints and authentication tokens? So we currently store our auth token related things in shared preferences. And on our debug builds, we override the provider for the shared preference, and we add a suffix to the key for the current endpoint that you're on. So for instance, on the release builds, we have a preference called app token. And on our debug builds, it'll be app token dash like staging, app token dash production. So then you're able to switch between endpoints, and because we're recreating the application every time, we're able to just change which key it's using every time you every time you change your endpoint. Makes sense? Cool. Yes. Yeah. So the gist of the question that I got was whether or not we recreate the activity graph or the application graph because of notifications and stuff. Yeah, come find me after. I'm having a really hard time hearing. But we do recreate the application graph entirely. Process Phoenix starts up in its own process, kills the old process, and then restarts your activity in the new process. So anything else? Yeah? So I believe the question was about sharing like a mock mode between Android and iOS. Are you talking about having like another server that you can control, or sharing like native code, for instance? So the benefit, I may be misunderstanding the question again, but the benefit that we get of shipping the mock mode in the app itself is that we take out all, like, we know exactly what we're going to get. We're not going to get a network failure ever, unless we want to. Come up after. Anybody else? All right. So as I said, I'm going to be uploading these slides. I will tweet about it if you want to see them. Thank you.